Hi everyone! Last time we met, we started Lesson 3, Scientific Inquiry. So just a recap of what we learned about. We talked about what is scientific inquiry, and talked about scientific inquiry refers to the diverse way in which scientists study the natural world and propose explanations based on the evidence they gather. And we talked about how scientific inquiry often starts with posing a question. These questions can come from your experiences, observations, and inferences, or sometimes you're just curious. And finally, before we left, we talked about developing a hypothesis and how a hypothesis is a possible answer to a scientific question. We also learned that sometimes your hypotheses are wrong, and that's okay because those often lead to further investigations. Today, we are going to finish reading pages 21 through 23 of Lesson 3. So let's get started. All right, starting on page 21, let's go through and number our paragraphs. How do you design and conduct an experiment? After developing your hypothesis, you are ready to test it by designing an experiment. An experiment must follow sound scientific principles for its results to be valid. You know your experiment will involve counting cricket chirps at warm temperatures, but how will you know how often a cricket would chirp at a low temperature? You cannot know unless you count other cricket chirps at low temperatures for comparison. So I definitely want to underline this key sentence in bold. An experiment must follow sound scientific principle for its results to be valid. I also know that I want to remember that after you develop your hypothesis, you're ready to test it by designing an experiment. So we need to develop that hypothesis first. Controlling variables. To test your hypothesis, you will observe crickets at different air temperatures. All other variables or factors that can change in an experiment must be the same. This includes variables such as food and hours of daylight. By keeping these variables the same, you will know that any difference in cricket chirping is due to temperature alone. First thing I want to do is I want to circle the word variables. And I want to remember that these are factors that can change in an experiment. The one variable that is purposely changed to test a hypothesis is the manipulated variable, or independent variable. The manipulated variable here is air temperature. The factor that may change in response to the manipulated variable is the responding variable, or dependent variable. The responding variable here is the number of cricket chirps. So some big key words in this paragraph. Want to remember manipulated variable. And I want to remember that this is the variable that is purposefully changed to test a hypothesis. And I also want to remember that it sometimes might be referred to as the independent variable. I now want to remember that the factor that may change in response to the manipulated variable is this responding variable or dependent variable. These are very important because we're going to be talking about these a lot as we start conducting experiments in class. Let's take a look at our Apply It box. A student performs an experiment to determine whether 1 gram of sugar or 1 gram of salt dissolves more quickly in water. So we need to 1. Control variables. Identify the manipulated variable and the responding variable. So what would be the manipulated variable? The thing that changes. This is the variable that changes. Yep, this one is whether we have sugar or salt. And then what would be the responding variable? This is the one that changes or is dependent on the manipulated one. So a responding variable this time is going to be time, how much time it takes the sugar or the salt to dissolve. What are two other variables in this experiment? So what are two other variables in this experiment that might change what happens? So two other variables are, right, the amount of water, and what else about the water? The amount and the temperature. Finally, let's draw some conclusions. Write a hypothesis for this experiment. So remember, a hypothesis is your possible answer to what's happening. So my possible hypothesis is that sugar dissolves faster than salt. All right, now let's move on to page 22. I'm going to number my paragraphs. Setting up a controlled experiment. An experiment in which only one variable is manipulated at a time is called a controlled experiment. You decide to test the crickets at 3 different temperatures: 15 degrees Celsius, 20 degrees Celsius, and 25 degrees Celsius, as shown in figure 3. All other variables are kept the same. Otherwise, your experiment would have more than one manipulated variable. Then there would be no way to tell which variable influenced your results. So my key word in this is controlled experiment. And this is an experiment in which only one variable is manipulated at a time. And all other variables are kept the same. And I want to remember that if there's more than one manipulated variable, there would be no way to tell which variable influenced your results. That's very important. Paragraph 2, experimental bias. In any experiment, there is a risk of introducing bias. For example, if you expect crickets to chirp more at 25 degrees Celsius, you may run experiments at just that temperature. Or, without meaning to, you might bias your results by selecting only the crickets that chirp the most often to test. Having a good sample size, or the number of crickets tested, is also important. Having too few crickets may bias your results because individual differences exist from cricket to cricket. So the one thing I want to remember here is that in any experiment, there's a risk of introducing bias. And I want to circle the word bias just so that way I remember where to find that. Something like having a good sample size is good to get rid of bias. All right, let's take a look at figure 3, a controlled experiment. The manipulated variable in this experiment below is the temperature. In the boxes, write the number of crickets you would test for the controlled experiment. On the line below, write 3 other variables that must be kept the same. So how many crickets do you think you would use at 15 degrees? I'm just going to say 8. And if I choose 8 for 15 degrees, how many should I have at 20? I should still have 8, which means at 25, I again should have 8. Now, up in the designing experiments box, remember we have to keep 3 other variables the same. So what other type of variables must be kept the same in order to make this a controlled experiment? I need to keep the type of container the same. Oops. The type of container. What's inside the container, so I'm going to say the container's contents. And the time. They must be kept the same. And our last page for today is going to be page 23, so let's go ahead and number those paragraphs. Collecting and interpreting data. You are almost ready to begin your experiment. You decide to test 5 crickets, one at a time at each temperature. You also decide to run multiple trials for each cricket. This is because the cricket may behave differently from one trial to the next. Before you begin your experiment, decide what observations you will make and what data you will collect. Data are the facts, figures, and other evidence gathered through qualitative and quantitative observations. To organize your data, you may want to make a data table. A data table provides you with an organized way to collect and record your observations. Decide what your table will look like. Then you can start to collect your data. Let's stop there. So there's a couple key things from this paragraph. So before you begin your experiment, you need to decide what observations you will make and what data you will collect. That's important. You want to make that decision before your experiment so it can remain the same throughout. Also want to remember the word data, and those are those facts, figures, and other evidence gathered through qualitative and quantitative observations. I'm going to circle the word data table because I want to remember that that's where I could organize ways you collect and record your observations. Paragraph 2. After your data has been collected, they need to be interpreted. One tool that can help you interpret data is a graph. Graphs can reveal patterns or trends in data. Sometimes there is more than one interpretation for a set of data. For example, scientists all agree that global temperatures have gone up over the past 100 years. What they do not agree on is how much they are likely to go up over the next 100. So I want to remember that after my data has been collected, it needs to be interpreted. I want to know that one tool could be a graph because they reveal patterns or trends. And I want to remember that sometimes there's more than one interpretation for the data, meaning that sometimes what I see might be a little bit different than what others see. Let's do the math. A data table helps you organize the information you collect in an experiment. Graphing the data may reveal any patterns in your data. So number 1, read graphs. Identify the manipulated variable and the responding variable. So remember, the manipulated variable is the variable that we change. So what is the one that we're changing? Right, that is our temperature. Our responding variable is what then? Our responding variable is the number of chirps per minute. All right, read graphs. As the temperature increases from 15 to 25 degrees Celsius, what happens to the number of chirps per minute? So looking at the graph, what happens to the number of chirps per minute? Right, it increases because we can see that the line in our graph is going up. How many chirps per minute would you expect if the temperature was at 10 degrees Celsius? So if the temperature was even lower, what could we expect? so looking at the averages from the number of chirps, I see that there's about a 40 chirp difference between each 5 degrees. So if it went down 5 degrees, I'm going to assume that the number of chirps would go down another 40 chirps. So I'm going to say I would expect about 40 chirps. There we go. Nice work today, guys. We were going to end our lesson there, and we will finish the rest of the chapter at a later time.